right, we got to do something different.
Well, I mean, you gotta love the enthusiasm. She's just excited to be out there, right? You know?
Yep, she enjoyed it.
Travis.
Hey, Travis.
What's up?
How's it going, buddy?
I don't know. Who can tell?
That's awesome.
Anymore?
It's very positive.
Always.
I feel like
Who
you're
needs to
under a
know as long as you
spotlight.
keep plugging along?
That's right. If you're busy enough, you don't notice how it's going.
Yeah.
Nope, not at all.
Is that busy work shoveling, or are you guys finally done doing that?
I've had enough of that for a while. You can have that shit, Randy. That's all you. I don't need any more of it.
Yeah.
Wait, so
Yeah.
Randy said you guys got like over a foot. Is that accurate?
Yeah.
Yes.
And it's staying cold. So it's usually like in Kansas City, we'll get like 2 or 3 inches and then it melts off in a week. And it's crippling our job sites.
Wow.
Randy, that's nothing, right, buddy?
Oh, we plan to be inside come 1st of December. We don't work outside anymore.
No, it's
Yeah,
that's
nobody's
the right
building
way.
decks and doing siding this time of year.
No.
Yeah, we've had some strange weather up here as well. It's nothing like you guys at all, but Mass doesn't usually get high winds, and for this entire week we've had like 30-mile-an-hour winds. So with the gusts and everything else, we've gone from what's normally about 24 degrees to like single digits and just blows right through you, and you're just like, what the heck is going on?
It's pretty miserable.
I wonder if we mistimed the below the surface roundtable, because I thought down here in the south, the house next door, they're pouring the concrete, I think between today and tomorrow. I've seen trucks. So I thought this was a perfect time to do it for a cornice slab. So that's on me. I apologize.
In your defense, Chris.
That's okay. Yeah.
In your defense, we are actually supposed to be installing comfort board right now for an underslab pour that was supposed to happen next week. But instead, Joe picked up propane and set a guy loose with a torch to melt off all the snow in the basement so that we could do comfort board next week. So it's really, you're only off a few days. It's really not
okay. All right. It makes me feel a little better. I appreciate it.
Always looking out.
Well, if you don't mind, do you mind if I transition into the
Sure.
why we're all here? I'm excited to be here. It's been a long time.
Yeah.
We had some time away. I missed my guys. I'm excited to have everyone back on. So if it's all right, I want to transition into it. Oh, thank you. Well, anyway, my name is Chris Caparucio. I am with Rockwell Insulation. I'm the key account manager for the builder development team here with Rockwell. On the call, we have the entire business development manager team, and a couple are on camera right now. We have Brandon Collins, who covers the Southeast United States, pretty much Virginia South, I'm pretty sure. Then we have Chris Jessen, the North Central Business Development Manager. Chris, I mean, you have a pretty massive area. You want to explain what the North Central is?
Yeah, so basically Colorado out to Michigan and then down to southern Missouri, Kansas. So about 13 states.
Pretty big geographical spread there. And then we get down over to Lewis Smith, the Northeast Business Development Manager. And Northeast being what exactly, Lewis?
Yep. We start in New York State, and that includes Manhattan. And then we work up towards New England, and we cover all of the New England states as well.
New York State does typically include Manhattan. I appreciate the
just in case. Just in case.
And then we also have Nick Stone, our residential architectural specialist. Nick?
Hi, everyone. I am covering the country, working on as many projects as I can with everyone.
So Nick and I are going to stay on as the quote unquote hosts for this one, but in the background we will have Chris, Brandon, and Lewis for Q&A. So if you have a question about something that comes up or a specific detail that we're talking about, feel free to weigh in, and those guys will be they'll be there to answer your questions. And if one of you wants to pop back on camera, if a question comes up that we're unable to answer, or it's specific to Walt, Joe, Travis, Randy, please pop back on and let us know. So without further ado, the rest of the people that are on screen here, we have, I mean, we might as well start at the top of this slide here. We have Travis and Joe. Guys, you have the floor.
Well, hello. I'll go first. I'm Travis Brungard. I'm in Prairie Village, Kansas. I'm a half owner of Catalyst Construction, custom home builder and remodeler. We do a lot of self-performed trade work, licensed in all the trades, of which I only get to carry 2, which leads to Joe, the other 2.
Yeah, I carry the other 2, and I'm the other owner. We're in Prairie Village, Kansas. We're under a foot of snow. We are doing our best to make it through. We're not used to getting this much snow and then the temperature just staying cold for more than a day or 2. So, and I'd love to say I love the picture that you used for this round table.
It's a good shot. Yeah, it's a good shot. So you're familiar with that, I think?
Yeah, just a little bit.
Perfect.
Those are the toes of my boots.
Well, with everything that you guys are going through right now, I appreciate you both joining. I appreciate it as always.
Oh yeah,
Randy, we have Randy Williams here. Randy, please, for the people.
Yep, I'm a little north of Chris Jessen. I'm in northern Minnesota, about 100 miles south of the Canadian border. I do not have nearly as much snow as Kansas City does. We are cold, but we're not don't have much snow. So I'm an educator, writer. I do work in the trades, energy auditing, building investigations, that kind of stuff. Yeah, the overall building science nerd.
And Randy, thank you as well for joining. Always on here, so I really appreciate it. Wealth of knowledge. Last but certainly not least, and before we introduce you, Walt, I actually want to show a slide that kind of introduces you. I tried to put as much as I possibly could on here, but there's just so much. I couldn't get it all on there. So Walt Tamala, please tell the people what you're about and why what's on screen is what's on screen.
So the joy is I have no idea what's on screen because my screen just keeps spinning in a circle. So I'm not sure what's going on. And that's probably, because I'm the old dude and technology is not not key for me. So I'm hoping I'm like on top of a roof or a ladder going like.
So that is one of the pictures. I also have a picture of your 40 under 40 award.
Oh God. That was a while ago. I look like a much younger man, I'm sure.
Well, I guess how about you just explain, your background.
Hi everybody. My name is Walt Tamala. I'm the owner of TNT General Contracting, a build, design, educate firm based here out of Westfield, Massachusetts. I started my construction company right out of high school. I went to one semester of college, realized that I loved working with my hands. I had been doing it since I was 12, and that business degree really wasn't what I wanted. So I jumped right out into the field. I started building bowling centers for AMF Industries, whereas I got most of my initial knowledge as far as what building on your own was like. And then I jumped right into being a part of the Home Builders Association, which was a wealth of knowledge and people for me to meet. I went through the ranks. I became a local president. I became a state president. And then I sat as the national director for NAHB for years before I realized that my kids were getting older and I just couldn't do all of that. Now that my daughter is in college and my nephew is in high school, I'm back participating in those programs. And I sit on the board for 3 trade schools locally because I really think that, as Travis and Joe can attest to, that like bringing on these students and getting them excited about our industry, especially when we talk about how great it is and the people that are in it and just what we're able to do, I think is a really important thing. So thank you for letting me be here. I really appreciate it. You got a great team and I'm happy to be a part of it.
Thank you for joining and thank you for talking about the education side too, because I know it is something that Travis and Joe harp on pretty seriously and on a regular basis, but it's something that you're also doing. and have been doing. So I'm glad you brought that up. So thank you. You've also used some of the products that we're going to be talking about in the applications during your building. So
Yes.
there's not just a dedication to the industry. There's a level of expertise when it comes to below grade insulation. Dealing especially up in New England, where there's a lot less just slab on grade, but you do have basements, crawl spaces, all that stuff. But today we're kind of going to stick to slab on grade for the most part, sub-slab insulation. But I appreciate you explaining your background. So
great, thank you.
Moving forward, since we are talking about insulating below grade, I felt like if we're back to basics, end of the first week of the year, let's just start easy. Why are we talking about this? Why are we talking about below grade insulation at all? Is it not just a no-brainer to insulate below grade? I mean, I feel like you can immediately say, if I'm insulating below grade, yeah, I probably will have improved thermal performance, and that may or may not improve the indoor comfort, that everything that's above that slab. And yeah, when we're talking about below grade applications, there's probably a level of moisture that could be involved in this system here. So increasing your moisture control never hurts. And then with the weather that we've been talking about, maybe that third point is one of the more important ones here, protecting your concrete from that freeze thaw cycling. I knew I was going to trip up on that, but the freeze thaw cycling, and I got through it. It's okay. But I mean, this is why you would do this. And traditionally, maybe things have been done differently, and we're going to talk about that. But this is really the why behind what we're talking about today. So if we do start to look at some of the traditional below grade, whether it's sub-slab or not, just below grade insulation types, I mean, Nick, what do you think immediately comes to mind?
If we're thinking about traditional, we got to go with the original OG dirt and rocks, baby.
I mean, that really is the most traditional below grade insulation type. That's where it all started.
How many times have you guys been into a building where you go downstairs, and even before you get there, there's dirt and rock somewhere, just by how it smells, how it feels, right? This is definitely one of the, at least in New England, where Walt and I are from, this is a very, very common sight. Walt, have you ever seen this before on one of your projects?
Probably half the projects we do every year or get called in to do estimates on, we walk into the basement. You can walk into the first floor and you know what the basement's going to be like. But yeah, half of them have no rat slab. They don't have any poured concrete of any structural component or anything of that nature. And half of the equipment is sitting on cinder blocks off the dirt so that it's just leveled in place.
Wow. Absolutely. This is such a common sight, but we just wanted to throw kind of what things were built like for years and years and years. But as we get a little bit more serious, as we transition into a little bit of the installations that we're using on more of a day-to-day basis, there are, three of them that kind of jump out, kind of stand out, which is your extruded polystyrene, your expanded polystyrene, and you'll see some of your polyisos going out there. A lot of them are very similar as far as how much moisture they absorb per volume, PSI and R value. Are these some projects, materials that you guys have used in products in the past, maybe out in KC? You guys use some of these products before?
I mean, we have. Travis and I helped with a non-for-profit. It was a big barn dominium slab on grade, and we went out there for a day and put down foam. We used to use the foil face stuff on our crawl spaces years ago because it met our insulation and our fire code.
Mm-hmm.
And since then we've transitioned to rock wool because we just think it's better. But and it's in our market, it's kind of hard to find the foil faced foam these days that actually meets the fire code.
Randy, what about you up north?
Hold on, I have a stupid question about the foil face specifically. I was going to ask, I mean, it's obviously they use foil for a radiant barrier or some level of radiating heat back, but is there any other value there, or is it specific to more the fire protection?
We were using the Dow Thermax, right? Wasn't that
Yep.
it? And I mean, I think sometime during COVID, it just stopped being available in our market, and I haven't found it since.
But that's
but yes, it was for the fire resistance. That was the main reason.
That's a little bit
Interior only.
different, right?
Correct.
Okay.
Yeah, that
Sorry.
tends to have a thicker foil face to it, a little bit different chemical makeup, if I'm not mistaken, right? Right, guys?
Mm-hmm.
Yep.
Yeah. But these, I think these are pretty commonly, found, all over the country. But there are, as you alluded to, Joe and Travis, there are some, some different options that are popping up on the market. Perhaps the original OG may be coming closer and closer to coming back with a little bit of rocks involved with a stone wool product, huh? You guys like how I transitioned
I see what you did there.
So as you guys know, we have a product called Comfort Board 80. It also is meant for below slab. We have a less than 0.05% absorption rate. It still has good compressive strength at 435 pounds per square foot, to 10% compression, or 1,065 pounds per square foot at 25% compression. Comes in various sizes, everywhere from 1 inch all the way up to 5 inch, pretty much in half-inch increments. And it's about a 4.2 Rs per inch. So very similar to the other products. But maybe, guys, you can talk a little bit about some of the spit it out.
It's all right. It's all right. It's early in the year. We're all tripping over words.
Right?
It's okay. It's all right.
Maybe we can talk a little bit about some of the projects we've been on, some of our thoughts on it. And maybe Walt, if you want to jump on this one, I think this is one of your projects that we're looking at right here.
So yeah, and you know what? Let me start with this. My first project with sub-slab, underslab insulation was in 1998. I had a walkout on a new house that we were building, and mind you, I was 5 years out of high school, and I just like to try and work with new things and build the best house possible. And we used XPS, and we used 2-inch, 2-layer, and back then, I was too naive to understand, like, hey, when the excavator was compacting, that perfectly level, that was not a thing for him, but that it was really important for us, because try putting XPS down even on 4x8 sheets and hitting a pocket and whatever, and all of a sudden it cracks underneath you, it starts to fall apart. I ran terrified from that job about doing sub-slab insulation ever again. I was like, this is crazy. My concrete guy hated every minute of it. We did more rebar and wire mesh in that in that slab than I'd ever seen. And we ended up doing a 6-inch pour instead of a 4. Obviously, I've learned a lot from then. The next time I did any sub-slab insulation was 2003. It was for my plumber, because he wanted radiant floor heat in his basement. He's a big Wiesmann guy, and I said, absolutely, for Bill, I'll do it. But yes, we leveled that stone and gravel, and we used actually some sand as well. And that went a lot smoother, but still not nearly as good as the picture you're seeing with the rock wool, the comfort board. We used the 110, Nick, not the 80 on this, just because of availability and what we were looking to do, because there's a garage also in this structure, so we wanted the weight rating and everything else, and it worked amazing. Again, I apologize, I don't know what picture is up, but when we first looked at this project, you're looking at a 36 by 36 auxiliary building, a pool house, and my clients and everything else, they were here like, Walt, we trust you. Whatever you say we need for insulation, let's do it. So I met with our building department. Go ahead, Chris.
It might be worth logging out and trying to log back in as we move to the next slide, because there are a lot of your pictures on this. So it may be worth just trying that link one more time.
So Travis, why don't I throw this question over to you, and I will try that link one more time.
Yeah, I mean, I'm happy to talk about our process. The way that Joe and I prepare under slab is with crushed stone. We don't use a lot of sand in our market. That kind of went away with people experiencing slab curl when they were pouring directly on to sand with slabs and experiencing a hydration issue with their concrete. So in our market, it's very common to use 3/4 crushed stone as a subgrade. The process that Joe and I use is to go ahead and bring our crushed stone base flush with a top of footing so that we can continue our comfort board. And we use the comfort board 80 under slab. That's our standard product there. We need R10 for our minimum code R value here. For sidewall, we use the 3-inch. We want R12 there. So we're running across the top of the crushed stone after we get it leveled off, running it exactly as shown in the detail there, so that our under slab condition, that insulation runs all the way over to the concrete stem wall, as is shown in that slab on grade or stem wall condition there. If you have that under slab insulation run into the side of your footing and then pour your slab on top of that, you have a thermal bridge from your concrete slab into that concrete footing connected directly to the earth. And I think Steve Basic has a slide in one of his presentations that talks about you basically negate 25% of your performance because that cold that you're getting at that 50 to 55 degree earth temperature, which is what we have here, will come in about 4 feet on your thermal imager. I'm sure Andy's got some cool slides with that picture in it somewhere, where you basically have a frosty cold edge around your nice warm interior condition if you allow that thermal bridge to occur. So we do basements here, so we have a taller concrete wall section that we're working with. But yeah, we're running our comfort board across the top of the footing directly into the wall where it goes straight up on the interior because we insulate to the interior.
That's something to put a pin in that for now, because that's
on that one.
We're coming back to that. I have a question about the sand, and this might just be me not being someone in the field here, but what is the benefit or the detriment to sand in different areas? We're saying that it's not seen towards the center of the country there in Kansas City area, but we are seeing it up in New England. Randy, is that something that's typical up in your area? Is sand used? It is, okay.
Yeah.
So why is that a part of the system here?
It's easier to work with. It's easier to make flat. It's easier to compact. When you get into the crushed rock, which is what I do crushed stone between a sand layer and the underside of the foam or insulation, whatever product we were using. That gives us our radon, right? That crushed stone portion, but it is a little bit harder to work with. Things aren't quite as flat all the time. You get a little more lumps and bumps in it. But for the most part, it's easy. It's not hard to work with. Yeah.
Same application where you use crushed stone, like crushed like stone dust.
No. We're using the only time I use the fines is if we were doing a concrete free slab assembly, the concreteless slabs. Then we'll use something like that because it packs really hard. We don't have to worry about it giving when we walk on it. Yeah.
I didn't mean to cut you off.
Go
ahead. Oh, and now I've done it
No,
twice.
you're okay. I was just going to say the reason we don't do sand here, again, it has to do with something that happened a lot in the 80s where guys would have slab curl where they would just pour a slab directly on the sand. The sand is not as free draining. The crushed stone engineers say it's self-compacting. It's not really. We can get it flatter if we compact it with a plate compactor. But the water can be held in suspension in sand much more readily because the particles are small. They fit together tighter. There's not the 3/8 drainage cavity that Straub wants us to have for free draining assemblies. And we do get that with our 3/4 crushed stone. There's big voids. The path for drainage is rapid. So we'll get much better slab cure in an old way before we did. We do a lot of, obviously everyone should be doing 6 mil poly, but I think is it 4 or whatever that's in the code, whatever it is, you need to definitely follow your local codes for your slab conditions. But for our purposes in our market, we 100% of the time use 3/4 crushed stone under all of our concrete pours, not sand, because it allows for a more uniform cure.
Walt, are we seeing pictures now?
I most certainly am.
Okay, perfect.
That's perfect.
Nick, I'm going to go back to you here because you had something to say about these, did you not?
Yeah, before we kind of get into these pictures here, I actually think that the soil, uh, below the slab plays a pretty big role, in my opinion, for obvious reasons, like you guys just said, for drainage, having proper sequence of going from bigger to smaller as you get closer to the slab. But my only question, the only thing that we really haven't talked about yet, is what kind of thicknesses are we talking about? I mean, can I get away with 2 inches of it? Or do I probably need quite a bit more? And what are some of the variables that play a role into determining how much we need in that area? Maybe Walt, since you just jumped back on, maybe you can talk a little bit of what you're seeing.
Sure. So, I mean, I guess it depends on the application if we're a slab on grade or not, or if we're doing foundations. Basement foundation, the Mass 10th edition, which follows the IRE, IECE 2021. R10 is what we need underneath slab. I've never put anything less than R20 down because I'm thinking if my walls need 13, then I'd rather have more than less. And when I'm doing 2 inches and 2 inches, I'm getting 4 inches, and I'm getting my R20 for that. And that back in the day was probably just because it was easy to get the XPS at the time in that thickness. So it was just pretty common. Nowadays and everything else, especially with rock wool, it's much easier to be able to order exactly what you need, what's spec'd. A lot of times we're letting our architects and engineers design that. Randy could probably speak more to that component. But yeah, we're usually putting 4 to 5 inches down up here now. And then the slides you're going to see, that was a 5 inch, and then we ran out and we actually converted to 4 inch just to get our 20. But we were able to do that with the rock wall.
In Vermont, it's pretty interesting that a lot of places. So as I cover the whole country, as Travis alluded to earlier, you really have to pay attention to where you are because so much of it does change from area to area. But in Vermont, we just bumped to minimum R20 for foundation insulation on everything.
Wow.
So it was that was a pretty big increase for us up here. So kudos to you for being ahead of the curve on all that. But as we transition into some of these two pictures here, on the left-hand side, this is more of a traditional, before we really got into energy efficiency, we were just doing slab right on top of good drainage, so that way we can dry that slab out. We get good drainage when the water table rises and lowers. This is definitely kind of where we started in a lot of our beginning, stages of wood frame buildings. And then as we become more involved and understand how installation works better, how the flow of energy across assembly works better, we've transitioned to more of these details that we see over here on the right-hand side. This is, I'm going to speak just as if I'm talking about Vermont here, then you guys can kind of talk about your areas. But in Vermont, this detail is almost identical to what we've had for about the last decade now, where we transition that insulation and we have this kind of step part on that outside foundation wall there, and then the insulation comes up to that top plate. And it's a challenging detail. Is this what you guys are seeing in your market? Are you guys staying away from that? In particular, I'm also questioning, I'd like to hear how you guys do that interior edge from a finish perspective. Maybe Randy, if you want to jump in on this one.
My printer's making a bunch of noise here all of a sudden. We actually, because stem walls get to be a little more challenging in our climate, our frost footing's 5 foot deep. That automatically, if you're doing slab on grade, that automatically, usually people want to just go to the basement at that point. But what we do see with slab on grades in my market are frost protected shallow foundations. So now we're insulating on the exterior across the bottom of the footing using something that has a higher compression rate, and then up across the bottom underside of the slab. So it's a continuous wrap all the way around, just like that. Yeah. Yep. The method that you're showing on the previous slide, yeah, not common in my market unless you get into a basement. A lot of our basements are ICF. It's just for whatever reason, that's what's been adopted in our markets. We've already got that interior insulation's already there. Now it's just a matter of insulating the bottom side of the slab and pouring. We're already protected pretty much. The slab's already thermally broken from the ground at that point.
What about you over with you guys, Travis and Joe? Maybe now we're headed south a little bit more. Maybe not necessarily on your projects, but either yours or somebody in your area. Do you see some more of this pop up, this style of design that you've seen on the right-hand side?
Yeah, I would say that's, I mean, it's really close to what we're seeing in our market. And it's pretty close to what Travis and I do with our full basements. We'll do our crushed stone insulation. We'll run that up the wall. And we usually now, on our last project, we went ahead and did all our sub-slab insulation, and then we did our wall insulation in one step, and then just had the concrete poured. And so that thermally broke the slab from the basement walls.
Now, how do you guys, so I've been in a lot of these designs where that insulation sticks out just beyond that bottom plate. Do you guys try to make sure that insulation stays below that bottom plate? Do you somehow make a little bit of a bigger bottom plate there to cover that? Or how do you detail that lower portion with that insulation coming up?
If we haven't really had that challenge, but I would use a bigger bottom plate. I think that'd solve it the easiest.
That Prairie Sun and Timber series that we're working with Build Show on now has this condition at the back wall. We do have that stem wall coming up, and we did execute it exactly as is shown there. And we did use a larger bottom plate. It was we blocked it in further also. So what we were trying to do is move that slab edge in. We really only needed a 3.5 inch bearing. So it was easy with the 2x6. We brought that in a little bit. And so we really only have is it 3/4, Joe? Of that slab edge, if you can see it at all in some areas.
Yeah, I think we're gonna just between sheetrock and base trim and shoe, it's gonna completely cover it.
I agree.
About a decade ago, when Vermont switched their code over to that, I was in a garage and they had 2.5 inches exposed, and we quickly had to figure out some different details in Vermont to cover that up. But the first year that code had changed, that was a detail that really plagued us. But like you guys alluded to, we quickly went to bigger bottom plates or offset that wall. But the first year, we just didn't understand that design until it happened. Walt, did you see any of that as Massachusetts quickly changed over as well?
We didn't. I haven't seen a ton of it. We've been doing this detail here for a while. As far as just the break from the slab to the foundation wall, it was a 1/2 inch. Now it's grown. So I think, Joe, what you guys were saying was that under slab insulation, you're then running straight up the interior wall, so you have a full 2-inch insulation. Yeah, I think that's brilliant. I think that's great, and that continuous thermal break is key. So that's awesome.
All righty, guys. We talked a little bit about this. Randy, is this called a mono slab? I've always called it an Alaskan slab. What was your?
Yeah, it's basically, as long as it's got a wing or a layer of insulation that moves horizontal away from the building, it's called a frost protected shallow foundation. Mm-hmm. So it's a monolithic pour, like you said. My details are very, very similar to that. I usually have a layer of continuous exterior insulation on the wall assembly. So I'm able to plane out that below grade insulation with the wall insulation. We don't have some of the markets, some of the areas in my market won't allow you to hang that bottom plate over very far onto that insulation. They're, for whatever reason, the code officials have poo-pooed that, if you I guess if you want to say that. They want to see pretty much all bearing on the concrete. So adding that a continuous insulation, or some people will cut a wedge on that exposed top edge, so it's got to add a slope to kind of line things up a little bit better. But then you got a funky water management detail that you got to cover up.
So there are a handful of different options on how you want to detail a slab on grade. Definitely some pros and cons, but this is a detail that I see every so often where they do spray foam that bottom. Not to get into too much of the weeds here, but how do you guys feel about doing that versus some of these other materials?
You mean the closed cell spray foam
Yes.
below grade?
Yep.
I've done it in a couple of instances. It's challenging. It adds it's really hard to get flat is the biggest thing. I know one of the projects that we did that on, I think it took an extra truckload of concrete to over what was estimated to get it upright. So yeah, you get the lows and the highs, and yeah, just a little bit. Well, it was I don't know, it was a 20 truck pour or something like that, but still, it was still a pretty miserable. Yeah, especially when they're coming 75 miles, it wasn't good. So that's one of the challenges. Yeah.
I think that pretty much says it all there. We're gonna quickly move on from that one. This is one of my favorite topics to kind of talk about. What is the sequencing of material here? How do you guys do it on site? Do you guys do vapor barrier insulation concrete, or do you do insulation vapor barrier concrete? What is your method? Why do you do it? Travis looks like he wants this one. Go, Travis, go.
Yes, we get questions like this through our Instagram all the time, and people are like, "Why'd you put that there?" It's like, because that's where it goes. I don't think that there's a lot to discuss. The vapor barrier should be on top for us because of our assembly. Keep in mind, these are responses to, I'm showing a video where we've compacted the 3/4 inch crushed over the dirt, flush with the top of our footing, and then laid out 3 of comfort board to cover the whole thing, and then put the vapor barrier down. We put usually stego and detail the corners really nicely, and then place the steel, and then place the concrete, and now it's a perfect assembly. But if you did it the other way, if you put your vapor barrier underneath your rock wool, now you have created, remember I was talking earlier about slab curl and hydration risk, you have created a really nice bathtub scenario where all of the moisture in your concrete has to exit the top of the slab because it cannot drain to anywhere, because your vapor barrier is also a water barrier. It's not going to go anywhere. It's going to be held there forever. And because we detail our vapor barrier to the concrete foundation wall, and then we place our insulation on top of that to the interior, what I would basically be doing is taking all of the moisture in the slab and migrating it into my wall insulation. And that is a bad move, because I might frame that interior wall and then drywall it. And now I've taken any moisture loading, which, let's say that somebody doesn't do a good job on their mechanicals and the condensate is just dumping across the slab for the life of the house to get to the floor drain instead of running that condensate in a dedicated pipe. If you load that slab with moisture, it's going to basically uniformly load that concrete. And so it's going to hydrate that slab and move out into that insulation and move up into those insulated wall panels, and then have to migrate back through the drywall. So what I want to do is seal out any moisture that's coming up. Say I'm in a wet area that we might have, the water table gets a little high during the spring rains or whatever. I've got all this moisture. I want to keep that away from my insulation, because insulation does a great job unless you load it up with water and make it conductive. Then it's not insulating you anymore. So I don't think this is a discussion with our recipe. However, if you want to use some pink stuff that's got a plastic facer, maybe you have a different discussion. We don't use that stuff. I'm not going to comment on that.
I'm glad you didn't feel strongly one way or the other about this. I would have been concerned. Well, I mean, does anyone else have a question about it or a thought? Because we do get this question as well pretty frequently when someone sends in their plans, and they'll ask, does this look right? Does this assembly match what Rockwool thinks about it? Obviously, we're not the only insulation manufacturer in this category, as we've shown in the last few slides here. So we feel one way about it, just like you do. But do you guys feel similarly? I mean, is this pretty uniform?
Yeah.
not common. It's opposite in my market is what everybody's doing. I'm trying to do education, trying to tell them, no, it should be on the top side. It really needs to be there. If you read Joe Stiebrick et al., buildingscience.com, he just recently discussed this. He had a video where somebody asked him this exact question, and he said, yeah, it's got to be on top. That's where it needs to be. So
it feels like the right answer.
For years, Travis and I were project managers for a semi-custom builder here in Kansas City. And part of our job, we'd have to inspect, make sure they have the vapor barrier down. They did not, this is way before any ideas of sub-slab insulation were even anywhere in the market. And it wasn't required either. But we would constantly see when you put your vapor barrier on the rock, and you have guys walking around, it would just get shredded. And we're like, this isn't actually doing its job. And once we moved it to our builds where we were putting on top of the insulation and using a little bit more of a robust vapor barrier, but even if we were just using, plastic from Home Depot, 6 mil plastic or 10 mil, it would probably still hold up. The softness of the insulation actually protects the vapor barrier. That's what we're seeing. And we're not seeing tears or rips or, just it being worn through.
No, it makes sense. And full disclosure, I did take these from Stego's website. So this is a question that is not just an insulation question. It's not just a vapor barrier question. I mean, it's a question about the assembly as a whole. So I appreciate you guys weighing in on how you do feel about it, because it's a question that I don't know should be as common as it is, and it feels like you guys feel similarly, but it's a question that's out there. And if we're talking about insulating below grade, you have to address this and be pretty clear and concise about what the thoughts are.
Can you guys help your friends at Stego out and send them Rockwell's white papers? Because part of the problem with this slide is that pink line. That's what's confusing people. If you get a nice green, thick bar there, then they'll know. Then it'll be like, oh, well, this is obviously right.
Well, a question just came in actually about this specific, and like I said, I thought that it was pretty clear, concise, but a question just came in. What about between layers of insulation? Let's say you are doubling it up and you got 2 inches and 2 inches, or 4 and 4, or whatever you're doing. Can you layer it between? Should you not? I mean, let's say you finished your assembly and you have installed it on top of your insulation, and then you want to put another layer of insulation. Should you just do all of the insulation, or should you sandwich it? I mean, well, it looked like you had a thought there.
No, I'm less concerned with that application than I am having it underneath all of the insulation. I think it's probably a half dozen of one or of another with that. I put all my insulation below and then just the vapor barrier on top, like like Travis was talking about. But the reality is, yeah, I don't know that I don't think you'd run into long-term issues doing it that way if you're doing multiple layers. But again, the best way is to go on top.
And obviously these are blanket statements for just in general, here's how we feel about it, but it could vary based on where water tables are in a specific area or what region of the country you're in. Like, things could change a little bit. But so these are blanket statements. So I do want to preface that. But yeah, I think it could be potentially, I don't know, complicating the assembly in an unnecessary way, potentially unnecessary way. But I'm with you. I don't think that it would hurt, but I don't see it improving the assembly.
So I think when using Rockwell, though, it's important to note that we are radically different than the other categories.
Sure.
Because we are vapor open, we really want that vapor barrier on top so we don't create that cup or bathtub situation like Travis talked about. And I really feel strongly with Travis, it's really the best location for at least with Rockwell to be using it on the very top.
Yep. I mean, that's a perfect transition too, because the next slides, these are the ones I was talking about, Walt, where we have your assembly that you put together here. So are you able to educate a little bit on what went down here on this slide here?
Yeah, sure. So on this 36 by 36 accessory building, it's a pool house, and 1/3 of it is going to be heated. year round. They have a bathroom, they've got a changing room, they've got a garage space that has to maintain a certain temperature with the components that they had in there. And we looked through a few things when this came about, and obviously we're now aware of Rockwool's products and what you had for availability. And not to shy away from it, we did our due diligence because there is another product out there that I was interested in that I wanted to learn a little bit more about, which was Glavel, right? And it was a nice product comparable to what you guys can do. But what we ran into is accessibility. You're going to see that one, we couldn't get it readily available, and it was a lot more work to work with it. Also in my market, I couldn't get Stego. So you're seeing 6 mil plastic there because you work with what you can,
Sure.
as a builder, especially after COVID, like our hands are tied in so many different areas. So having Rockwool and the availability to use it was awesome. And again, it didn't matter where I wanted to go for it. You guys, your distribution and everything else had it readily available. So you're going to see that on the lower picture, as we're looking at it, the left-hand side was all the 5-inch product. And we laid it in. We got about 2/3 of the way through it, where all of our piping and everything else was. It worked out great. It was so easy to work with. It was easy to drill for our piping. We were able to get tight fits around piping and everything else. And the water lines and everything else have 2-inch sleeves below it. So again, it fit so nice and snug and tight and worked so well that, when we ran out of it, we're here like, well, now what do we do? Because locally, we didn't have the 5-inch at the 110, but we could get 2-inch. And most of our lumber yards could get it in within a couple days. So we went to the 2-inch. I brought my grade up an inch on the other side, and I still maintained an R20 underneath that entire area. The compression ratio of the 110 is night and day compared to the 80. And that's not saying anything bad about the 80, but I'm pretty sure there's pictures on the internet of Travis standing on top of the 110 at one of our international builders show, right? And over open sawhorses. And I remember the day I saw him jump up on that, I went, oh, sugar honey iced tea. This whole session in front of everybody just went south. But it held his weight, and I was sold immediately on it. I was just like, the product's amazing. So we did, the 110, I would say in a day total, we had all of this laid out, ready to go. Cutting it was simple. You see the tools in the left-hand side there. That's all we used to cut the product. And again, I had myself and one trade school student working on this.
Was that on that drill? Is that a Forstner bit or a whole hog
yes,
bit?
It is. Yes, we just bored right through it. I don't want to deal with hole saws and picking things out afterwards. No, just drill right through and be done.
That's good. But it was an okay install. No real issues when you were working with it.
So the nice part is, I was talking earlier about like the XPS and having everything perfectly level. Because of the compaction ratio and everything else with the Rockwool, if we were off slightly, and you can see some areas where it was a little higher low, it didn't matter. Like everything fits so snug together that it just holds in place. And even the young man that was working with me at the time, he's moved on. He's graduated now, and now he's running a framing crew. He's like, well, I can't believe how easy this stuff is to work with. And I'm like, yes. And this is when a manufacturer gets it right and is paying attention to the needs of us as a builder and contractors and folks out in the field, right? They're thinking about not just, bringing something to market. They're thinking about how does this make their life easier as well?
Yeah, no, I appreciate that feedback. And it looks like a beautiful install in these pictures. I mean, it looks like it's a pretty clean install, but what looks even cleaner, and I have to give you your flowers here, that is a gorgeous finished product.
Yeah,
and we're not shiny and beautiful, and we're not the finished product, but this is just cool to be a part of.
So it was a great project, and Travis and I had talked about this with the truss systems and everything else. But no, it turned out phenomenal. If you could go back to the other slide though, because pretty is what everybody wants, but in that the lower right hand picture, if you look to the upper left portion of that, you're going to see that I actually have 2 inches of rock wool sticking up on the left hand side of that. And that's because I wanted my insulation to be continuous all the way up the exterior wall. So when you look at that finished product and everything else, you're going to know that behind that cladding, rock wool is run all the way up, all the way to the peak, and all the way around the outside walls, so that I do have a thermal break all the way around this entire structure.
We may have to bring you back when we're talking about the continuous exterior insulation versus outsolation debate, because that was a cool detail that you had. I didn't include it in this one just because we're talking about the all below grade sub-slab stuff, but it was a beautiful detail. And again, how can you hate this? This is just a gorgeous finished product.
Thank you.
Appreciate it. So tell me you love building performance without telling me you love building performance is what Walt just did right there. That is a mic drop situation, because this is gorgeous and he's worried about how perfect everything else is. I love it. I love it, Walt.
How long did this take, start to finish, give or take? I mean, what was the timeline?
Because of some weather and also some decisions that took a little bit longer from the client. What was going to be a 6-month build ended up being 8.
Okay.
But yeah, start to finish, it was 8 months.
Well, I can't say enough about it. I'm a massive fan. This is really cool.
Thank you.
Yeah,
it was a fun build, and the clients are wonderful.
At 8 months,
I have to say,
that's still pretty good.
Yeah, I wasn't disappointed. I just, like you guys, you give a timeline and you're like, oh man, I know I can do it in that. So the minute that something changes and cabinets are 12, 14 weeks instead, it just.
Oh, yeah.
Walt, I seem to remember a phone call and you saying the exact opposite of that.
good things are worth the wait, Nick Stone. Good things are worth the wait.
Oh, Walt.
Well, no, I appreciate you sharing,
Sure.
the pictures that you did, the process that you went through for this build. I thought it was just a perfect example for what we were trying to talk about and what we're trying to illustrate for this roundtable here. But really, that finished product is incredible. So thank you again for sharing all this stuff with us.
Absolutely, happy to.
Before we kind of wrap up, because we are getting to the back end of the hour here, Nick had something to bring up about code with relation to the insulation that we're talking about, or the area of insulating that we're talking about.
So often, we talk about what we're doing. You guys are all so fantastic. We're going above and beyond. But when you start looking at the actual code and how it's written in different portions, going back to Travis said earlier, pay attention to where you are. This detail here is actually a very legitimate detail for quite a few different areas, where when you read the code, it does suggest that you have to minimum bring the insulation in 4 feet from the outside perimeter. And then it has to transition all the way around the building, but it doesn't have to go underneath the whole slab. I'm not saying that one way is better than the other, but just to point out that this is, in fact, how the code reads in quite a few areas. I have a suspicion you guys have an opinion on this, and I'm very curious your opinion.
Yeah.
Does anyone want to field this one first?
I just wouldn't. I could see if you're a production builder, you just do the code minimum. But in my opinion, it's like if you're going to do that, then you may as well fill the rest of it in. It's silly. We'll see it with sometimes if you're building a garage or something that's too close to a property line, they're like, well, you have to sheetrock this one wall and then 4 feet over for fire code. And there's guys that will do that and leave that for their client. Like Travis and I was like, well, let's just sheetrock the whole garage. It's not that much more. And the finished product, it's always cheapest to do it the first time, especially with sub-slab insulation. You get one shot at it. And it's going to make a big difference to your clients.
Yeah, you get in my market where our ground temperatures in the winter are in the 40s. That center of that slab isn't going to be. I mean, it's not going to be 40, but it's not going to be warm. It's going to be not fun to walk on.
Yeah, a notable difference.
Mm-hmm.
That's my argument to anyone who would suggest that you want to save budget in that area. I would ask them what they consider their ideal comfort temperature to be, and if they answer, mid 40s on the foot, then good. We can deliver that all day. In fact, we don't even need to build. You can just walk outside most of the year. It might be too warm for you in the summer, but otherwise, why build? It's very simple to me to, like, if you want to be comfortable here, you would also like to be comfortable over here. And one of these simple things that we can do to make sure that happens is to make things continuous. It's very, very affordable. And it's really hard to hear a compelling argument against doing the whole thing. It really is tough for me. So don't call me to insulate your outside 4 feet.
Well, I know Glenn always says that building to code is not bad building. I mean, building to code is good building. The code is there for a reason, and it continuously improves. I mean, it's never backtracking. It's always getting better or more efficient. But what you're talking about is not to code. You're saying I want to do just a little bit. That little bit is a difference, and it's a noticeable one between where a lot of people are building and where our standards are. So
yeah,
it's just interesting to see what the code is.
Code is minimum standard.
Yeah.
So you're doing the bare minimum if you're following code. And there's little things that you can do as a builder that, sealing your sill gasket is $20 in like maybe an hour. And that makes such a huge difference in your air control layer. Just all these little things, they add up to just better performance for your client.
Well, with regards to performance, I have some thoughts for next time, because we are still, we're building from the ground up. So we just started with Sub-slab, and next time we're going to be talking about some crawl spaces, whether it's a conditioned or unconditioned. What are the best systems? How are the best practices being performed out in the field? When you're talking about doing something, what's best for your client, what's more beneficial here? Is it the sub-slab insulation? Is it the ground that they're walking on? Like Randy was just saying, you can notice a temperature difference from spot to spot. Or is it insulating the stem wall? What's more beneficial? Ideally, you do both, but what's more beneficial? If you have to pick and choose here, what makes the most difference? If someone's going to skimp somewhere, where do you not want to skimp?
From the bottom plate down about 2.5 feet, because it's exposed to exterior temperatures. So exterior wall, I think I'm not wrong about that, but Randy's on this, and so is Nick Stone. So I'll shut up now and ask the experts.
My climate, you can't have enough insulation. I mean, you're code. If actually, as a matter of fact, in my climate, code's going to require insulation in both areas. We can't get around it. So, yeah.
But in terms of heat loss, where is your greatest heat loss at? Is it
Or the wall?
You're still tied to earth. It's going to be greatest the closer you get to the top, right? That's where the biggest delta T is.
I just wanted you to say I was right. Can you just say I'm right?
You're right.
Better for me.
You nailed it. You nailed it, Travis.
He's nodding along with you.
I had his back. Absolutely.
Okay, so that one was an easy one, but I did have one more.
This one is really the good test, Travis. You ready? Go for it, Chris.
So again, just thoughts for next time. Which design has the greatest impact here? Is it exterior foundation insulation, or is it moving to the interior of that foundation?
Oh boy!
Where's Chris? All right, Travis. I guess I'll be the punching bag. Let's go, buddy. Next time.
Yeah, let's definitely talk about this next time, because this is a long one. Because you can say which has the greatest impact, but if you don't have a durable exterior to protect that insulation, and there's a groundwater condition, is it still impactful? Greatest initial performance, I don't think there's any question. However, durability of the interior of my house versus the exterior of my house, just saying.
And there's a mic drop.
Right out of his ear.
No, this obviously is a bigger conversation, but my point in putting this in here was when we're talking about stuff below grade, and obviously as an insulation manufacturer, we're just looking at the insulation as our key focal point. But there's a lot more than just dropping some block into the ground or pouring a slab and moving upward from there. Like, there are a lot of details here that do make a difference. The materials make a difference. The building practices in general make a difference. The choices that you have to make with some of these things, whether you go interior or exterior, how thick you go with some of this stuff, it makes a difference. Yes, sir. Go ahead, Travis.
I can't let it pass. I'm sorry. In this drawing, how could you establish thermal continuity? Your thermal break from your underslab condition has been severed by your foundation wall in this illustration. So Absolutely. Your footing is ground temperature, and it's emitting. It's allowing heat transfer from that cold footing. Heat goes to cold, so you're going to lose your interior heat into that stem wall. It's going to go down into that footing, and you're losing the efficiency. I don't know. Maybe there's another solution. I'm trying to think of an easy one. It would be difficult to put insulation on top of the footing and under the wall. If there was only a way to, I don't know, make that continuity restored by putting that insulation on the inside, maybe. I don't know. We'll talk about it next time.
Yeah, take that, Google Images. It's not our detail, clearly, but I appreciate it. So,
just saying,
guys, that was it. It was just a couple thoughts for next time. I really appreciate the discussion. It was awesome seeing you guys. Walt, thank you again for sharing the details you did for your project. The pictures were beautiful. I had a great time here. It was nice to get back into this. So yeah. I can't thank you enough.
Thank you, Chris.
Can we try something else?
Awesome.
It's good seeing everyone.
Can we wrap it up with stay our classy?
Ooh, I like that.
Yes.
Nick, send us out with that. Do it.
All right, everyone. Thank you all for coming. And as always, stay our classy.
Oh, it was great. One take. Perfect, Nick. It was perfect.
I love it, guys. I love it. Thank you guys so much.
Yeah, thank you, everybody.
See you next time.
Oh, that was great.
All right.
Thank you.
Bye.